For this experiment, we'll be using 60 milliliters of glacial acetic acid along with 60 milliliters of H2O and 40 grams of sodium hydroxide, which the formula would be HC2H3O2 along with H2O and NaOH. This process will lead to the double replacement reaction of hydrogen acetate reacting with sodium hydroxide yield to form sodium acetate and water. This would be acid plus a base to form salt and water. So in this case, the sodium acetate would be the precipitation of this process. First, use scapula and measure out 40 grams of sodium hydroxide into the weigh boat. Pour 60 milliliters of water into the 1 liter beaker that is on top of the hot plate. Then carefully pour in another 60 liters of glacial acetic acid into the beaker. Remember to wear goggles and gloves while doing this process. Then add 40 grams of the sodium hydroxide bit by bit.
When sodium hydroxide fully dissolves, take the beaker off the hot plate and wait for it to precipitate. Then place the beaker into the iced water.
You will know the precipitation process is starting when the solution is slowly starting to bubble. Once the solution is cooled and precipitated, pour the substance into an Erlenmeyer flask and be sure to scrape off the solid precipitate into a new weigh boat. These crystals will play a main part in triggering the crystallization process.
Place the Erlenmeyer flask into a beaker with 100 milliliters of water. Then add the thermometer to measure initial and final temperature of the water. Place the Erlenmeyer flask with the saturated solution into the beaker with a thermometer and 100 milliliters of water. Fold the weigh boat gently, leaving an opening, and pour precipitated solid into liquid sodium acetate.
This process would be known as the phase change from a liquid to a solid. As you can see here, the crystallization process is immediately being developed as the solid precipitate is being dropped into the liquid acetate. In order for crystals to be formed as shown in the picture, heat had to be released to its surroundings. This would also be known as the exothermic reaction. This process causes the Erlenmeyer flask and the water within the beaker to be relatively warm since the sodium acetate had to release all the heat in order to crystallize.
In this lab, the saturated sodium acetate reacts with the precipitation from the sodium acetate. In order for this reaction to take place, heat has to be released from the substance so the two forms can crystallize. To solve for the heat energy released, we use a specific heat formula, which is Q equals mc delta T. Q is the heat energy, M is the mass of the sodium acetate, also known as a substance, C is the specific heat of water, and delta T is the final minus initial temperature of the water, also known as a change in temperature. We first took the mass of the sodium acetate and multiply it by the specific heat of the water, which is 4.18 joules per grams degree Celsius. Then we multiply it by the change in temperature to get 1,222.21 joules. And due to our limiting factor of 7.3 degrees Celsius, we rounded to 2 sig figs, which is 1,200 joules.